Now, we started to look at what the interference pattern would look like from more than 2 slits. We can see that as the number of slits n increases, the primary maxima remain at the same spacing of just a double slit, but they become narrower and brighter, while secondary maxima become negligibly small. Now, the limit of this is the diffraction grating. Diffraction gratings consist of a very large number of equally spaced slits. When light passes through, the pattern on the screen is the result of combined interference and diffraction. Each individual slit has its diffraction pattern, and combined with all of the slits you have interference as well. You can have transmission gratings where the light passes through a very thin grating, but you can also have reflection gratings where parallel grooves are cut into the surface of a reflective material. These both have the same condition for a maximum in the intensity of the light. So the condition for a maximum is the same as it is for a double slit. We have d sine theta for a bright fringe equals m lambda, where m is naught and then plus or minus an integer. So m, as with double slit, is called the order number of the diffraction pattern. So since the diffraction angle for a particular order depends on the wavelength, a diffraction grating will act like a prism in spreading light out into its component wavelengths. Now, as with a double slit, there is always a maximum at 0 degrees, and we call that the 0th order. That is the light that has gone straight ahead. Then there is the first order to either side, and the second, and so on. Now here's a question for you. These patterns were made with the same diffraction grating using light from 3 different lasers. Why is the spacing of the spots different?